Hi guys. Today we're changing our A again, and today we're going to make a whole number. For the purposes of our videos, I'll make it a positive whole number, and we can work with negative whole numbers while we're in our live class session later this week. But let's get started. I attached another flowchart, so if you need to print it out again for your notes, go ahead and do that. And here's our first example. Y equals 2x squared plus 8x plus 6. As always, I'm going to start by identifying my A, B, and C. In this problem, my A is 2, my B is 8, and my C is 6. My A is positive, so this parabola will open up and it will have a minimum. To find my axis of symmetry, I will be plugging in negative B, which is 8, over 2 times A, which is 2. That becomes negative 8 divided by 4, and negative 8 divided by 4 is negative 2. Don't forget the x equals. That's mandatory formatting for your answer on the axis of symmetry. X equals a number. Next, I will take that negative 2 and plug it back into the original equation. So everywhere that there was an x, I will be replacing it with a negative 2. Don't forget your order of operations. We have to square the negative 2 before we multiply. PEMDAS, exponents comes before multiplication. Negative 2 squared is positive 4. After I've squared the negative 2, now I can multiply the 2 times 4 together. Now I've already kind of started dealing with the end of the problem, right? 8 times negative 2 is negative 16. I'm also going to go ahead and do negative 16 plus 6 is negative 10. And 8 minus 10 is also negative 2, so my y-coordinate is negative 2, and we already found our x-coordinate is also negative 2. That means my vertex is at the point negative 2, negative 2. Don't just circle what you found for y. You have to write it as an ordered pair. My y-intercept should be at where the letter C is. In this problem, the letter C is 6. So my y-intercept is 0, 6. All right, let's graph. Remember, we always start the graph with our vertical invisible line, the axis of symmetry. In this problem, it's at x equals negative 2. Next, I'll place my vertex on that line. So negative 2, negative 2. So I'm already at the negative 2, and then I'm going to go down 2, put a dot. Everything we've done so far has been pretty similar to what we've done in the past couple days. So we're going to change, though, our special order pairs. This is where things get a little bit different. So remember that the y-coordinate on your special ordered pairs needs to be multiplied by the letter A. And in this problem, the letter A is 2. That means that our y-coordinate will actually change to a new y-coordinate. For my first special order pair, instead of 1, 1, now it's going to change to 1, 2. We talked about this earlier. When your A is a whole number, your parabola is going to get skinnier. And it's going to get skinnier because it's rising faster. So instead of going over 1 and up only 1 space, I'm going to go over 1 from the vertex and up 2 spaces. For my next special order pair, it will change. It was 2, 4, but now it's going to be 2, 8. Going back down to our vertex, all the way down here, I'm going to go over 2 and up 8. Look, I just put a dot on the y-axis. Let's make sure that's in the right spot. So let's see, I put a dot. I went up 8 to get to that dot, but I didn't go up 8 from the origin. So we need to recount from the origin. So from the origin, it's 1, 2, 3, 4, 5, 6. Perfect. We thought it was going to be at 6, and it is at 6. Now I do want you to write your final special ordered pair, which has now changed to 318. But 318 does not fit on the graph. There will be a spot, however, on your homework and on your quiz and test where you will need to tell me what are the special order pairs that you used. So it is important that you write these down and then connect your dots with a nice curve shape, a U shape. All right. We have one more question that we need to answer, which is what are the x-intercepts? Now, when I did my first special ordered pair, I did notice that I drew some dots on my x-axis. And so I will have two distinct x-intercepts. That means I need to write two separate ordered pairs, one for each dot. Starting at the origin, the first dot that I come across is this one right here, which is at -1, 0. And then if I go to 3, -3, 0 is my other x-intercept. Remember, x-intercepts have to be written as two separate ordered pairs. That's the end of our first example.